Let's talk about implicit differentiation. We have this simple example x squared plus y squared is equal to 1. To do implicit differentiation, start by differentiating each side of the equation. The derivative of x squared is 2x, and for y, it is 2 times y prime because you are differentiating with respect to x, so you treat y squared as a composite function. The 1 is a constant, so its derivative is 0. We now have 2x plus 2y times y prime. To isolate for y prime, we move 2x to the other side, so 2y times y prime is equal to negative 2x. Finally, divide both sides by 2y, and we get that y prime is equal to negative x divided by y. Let's look at another example. So we have y times cos x is equal to x. To differentiate on the left side, we use the product rule. So y is y prime times cosine x, plus y times negative sine y, and on the right side, the derivative of x is just 1. So we have y prime times cosine x minis y times sine x is equal to 1. Now we move y times sine x to the other side to get y prime times cosine x is equal to 1 plus y times sine x. To isolate for y prime, divide both sides by cosine x, and we get that y prime is equal to 1 plus y times sine x divided by cosine x. Here is another example. We have the square root of x plus the square root of y is equal to 5. Before we differentiate, we will convert the format of the equation to something easier so we can differentiate it. The square root of x and x is equal to x to the power of half and y to the power of half, and we keep 5 the same. Now we can differentiate, so we get 1 over 2 times x to the power of negative 1 over 2 plus 1 over 2 times y to the power of negative 1 over 2 times y prime because they are both composite functions. On the right side we have 0 because the derivative of a constant is always 0. Now x to the power of negative 1 over 2 is equal to 1 over the square root of x, and same applies to y, so to simplify our equation, we will write 1 divided 2 times the square root of x plus y prime divided 2 times the square root of y is equal to 0. Next we move 1 divided by 2 times the square root of x to the other side to get y prime divided 2 times the square root of y is equal to negative 1 divided 2 times the square root of x. To isolate for y prime, divide both sides by 2 times the square root of y. So our final answer will be y prime is equal to negative square root of y divided by the square root of x. Here is another example. We have ln x plus ln y is equal to 2. This is a simple example and we can differentiate right away. The derivative of ln x is 1 divided by, and the derivative of ln y is 1 divided by y times y prime, which is basically y prime divided by y. The derivative of 2 is 0. Now we move the 1 divided by x to the other side, and we get that y prime divided by y is equal to 1 divided by negative x. To isolate for y, we multiply both sides by y, and we get that y prime is equal to negative y divided by x. We have one more example, which is a little bit harder than the other examples. So we have e to the power of cosine y is equal to x cubed times sine y. Let's start by differentiating the left side first. So the derivative of e to the power of cosine y is e to the power of cosine y times negative sine y times y prime. On the right side, we have to do the product rule to differentiate. So we get 3 times x squared times sine y plus x cubed times cosine y times y prime. Now we have negative y prime times e to the power of cosine y times sine y is equal to 3 times x squared times sine y plus y prime times x cubed times cosine y. Let's move all variables that include y prime to the left side so we can factor and isolate it. After factoring the y prime out, we divide negative e to the power of cosine y times sine y minus x cubed times cosine y by both sides so y prime is isolated. Our final answer is y prime is equal to 3 times x cubed times sine y divided by e to the power of cosine y times sine y plus x cubed times cosine y.